You spent months building your game's mechanics. Your players will decide if it feels good in the first 2 seconds. Not after reading your tutorial, not after the third level. 2 seconds. And if it doesn't feel right, they're gone, no matter how good your design is. Here's the thing most devs get wrong about game feel. They treat it as polish. You finish the mechanics, you finish the levels, and then you sprinkle on screen shake and particles and call it juice. That's backwards. Game feel isn't something you add at the end. It's a feedback loop between the player and your game, and it starts at the architecture level. The formal definition comes from Steve Swink, who wrote the book on this literally. He defines game feel as the real-time control of virtual objects in a simulated space, with interactions emphasized by polish. The key phrase there is real-time control. Feel happens in the loop. Player presses a button, the game responds, the player reacts to that response, and the cycle repeats 60 times a second. That loop is your game. Everything else is decoration. Let me show you what I mean. Imagine a basic platformer, a grey box on flat ground. You press jump, the box moves up, it falls back down. Functional, correct, completely lifeless. Now watch what happens when we apply 4 techniques in the right order. Before the box jumps, it squashes down for 2 frames, loading up like a spring. When it leaves the ground, it stretches tall. On landing, it squashes again and a burst of dust particles kicks up from the surface. The camera dips slightly on takeoff and bumps up on landing. There's a 4-frame freeze the instant the box touches the ground, just long enough for your brain to register the impact. Same jump, same arc, same gravity, but now it feels like something. That transformation took maybe 50 lines of code. The trick isn't the amount of juice, it's the sequence, and most devs get the sequence wrong. There are 6 layers to game feel: input, response, context, aesthetic, metaphor, and rules. Most devs jump straight to aesthetic, which is the particles and the screen shake and the flashy stuff. They skip response and context. That's why their juice feels like a coat of paint on a rusty car. At GDC this year, the design lead on Battlefield 6, a guy named Jac Carlsson, put it perfectly. He said game feels about how the game responds to you and then how you respond to that over and over again. Carlsson came from choreography. He literally designed dance performances before he designed game feel for a military shooter. His insight is that feel is a loop, not a state. You don't have good game feel. You have good game feel in motion, or you don't. So let's break down the 4 techniques that give you 80% of perceived game feel. And more importantly, the order you should apply them. Technique 1, hit stop, also called freeze frames or hit pause. This is the single highest impact thing you can do. When 2 objects collide in your game, pause everything for 2 to 6 frames. That's it. At 60 frames per second, 4 frames is 67 milliseconds. Your conscious brain doesn't register it, but your subconscious absolutely does. It creates a sense of weight and impact that nothing else can replicate. Hades does this on every single hit. Celeste does it on dash impacts. The reason it works is that your brain needs a tiny slice of stillness to process something important just happened. Without it, impacts blur together. With it, every hit lands like a punctuation mark. Implementation is trivial. When a hit registers, set a timer, skip your update loop for that many frames, then resume. 4 lines of code. Technique 2, squash and stretch. This is the oldest animation principle in the book, and it applies to everything in your game, not just characters. When something changes state, it should visually deform. A character jumping squashes down before launching. A health bar taking damage compresses and bounces back. A damage number scales up quickly then settles. The psychology is straightforward. Deformation signals change. A static sprite that teleports between states feels broken. A sprite that squashes and stretches between states feels alive. Donkey Kong Bananza takes this to an extreme. At GDC this year, Nintendo showed how every impact in the game deforms the voxel environment, and that deformation reveals hidden areas and collectibles. They called it the chain of destruction. The squash and stretch isn't just visual feedback, it's gameplay. For your game, start with your character. Add a scale curve on jump, squash to 0.8 height and 1.2 width on the frame before takeoff, stretch to 1.3 height and 0.7 width at the peak of the jump, squash again on landing. That's one tween call. Technique 3, particles as feedback, not decoration. Most devs add particles because they look cool. Wrong reason. Every particle system in your game should answer a question the player's brain is asking. Did I land dust particles from the feet? Say yes. Did my attack connect sparks at the impact point? Say yes. Did I break something? Debris flying outward? Says yes. Each particle system is a tiny feedback loop confirming the player's action. The difference between no particles on landing and a small puff of dust on landing is night and day. And notice I said small puff. The mistake is going overboard. You don't need 100 particles. 8 to 12 sprites, scaled between 0.3 and 0.8. With a lifetime of 0.15 seconds and slight gravity, that's a landing fill. Anything more, and you're creating noise, not feedback. Technique 4, input forgiveness. This is the one most devs skip, and it's the foundation everything else sits on. Coyote time means the player can still jump for several frames after walking off a platform edge. Input buffering means the game remembers a button press for a few frames before the action is technically valid, then executes it when the window opens. These aren't cheat codes. They're not making your game easier. They're making your game respond to what the player meant to do, not what they technically did. Celeste, one of the tightest platformers ever made, gives you 5 frames of coyote time. 5 frames, that's 83 milliseconds. And on top of that, it gives you 11 frames of jump buffering. So when you press jump slightly before landing, the game remembers it and executes on contact. Stack those two together, and the perceived forgiveness window is massive, even though each system individually is tiny. That's the trick. Small, invisible systems that combine into something the player feels but never sees. Implementation. When the player leaves a platform without jumping, start a counter. If they press jump before the counter reaches your threshold, execute the jump anyway. That's it. A variable, a counter, and an if statement. Now here's why order matters more than amount. These 4 techniques form a dependency chain. Input forgiveness makes your controls feel responsive at the foundational level. Hit stop makes impacts feel real. Squash and stretch make state changes visible. Particles confirm actions. If you skip input forgiveness and go straight to particles, you end up with flashy effects sitting on top of mushy controls. And that actually feels worse than no effects at all, because the visual feedback promises a level of responsiveness the controls can't deliver. It's like a restaurant with a beautiful dining room and a kitchen that can't cook. The presentation raises expectations that the foundation can't meet. There are 4 common mistakes I see over and over. First, adding juice to compensate for bad base controls. If your character movement feels wrong before any juice, juice won't fix it. Fix the movement first. Second, overusing screen shake. Screen shake should be directional and proportional to the event that caused it. Random omnidirectional shake just makes players dizzy. Third, ignoring sound. Game feel is multisensory. A perfectly timed visual hit stop with no audio impact feels broken. A single bass hit sound synced to that freeze frame completes the effect. Fourth, using the same juice for every action. Every action in your game needs its own feel profile. A light attack and a heavy attack should have different freeze frame durations, different particle counts, different squash curves. Generic juice is barely better than no juice. Here's where AI tools change the math on this. The design decisions, which technique, how many frames, what intensity, those are yours. But the implementation is boilerplate, and that's where AI eats. You can prompt Claude Code to generate a complete hit-stop system with configurable frame counts per action type, and you'll get working code in 30 seconds. You can describe a squash curve to cursor and iterate on the feel by saying make it snappier or more bouncy, and it adjusts the tween parameters. You can generate fill presets for different game types, a platformer profile with light freeze frames, generous coyote time, and big squash curves. A shooter profile with heavier hit stop, directional screen shake, and smaller particles. The AI handles the tedious implementation so you can focus on the design decisions that actually require your judgment. We're building complete juice systems like this inside AI Craft, with AI handling the tedious implementation so you can focus on getting the feel right. Join the community, grab the juice system template, and make your game feel professional in an afternoon. Please feel free to subscribe and check out the links in the description below.